off by taking a look at, this is like the very first page in your packet. I want to look at this diagram. What we're going to do today is graph quadrilaterals and then classify them as all these other different shapes that we've learned about. Quadrilateral is the most basic of our shapes. It's literally just any shape that has four sides. So everything that we talk about is a quadrilateral. But then, like, maybe you've heard, oh, a square is a rectangle, but not all rectangles are squares. We're kind of using that logic here to then talk about the other categories. The other categories start with how many pairs of parallel sides does each quadrilateral have? If it has no parallel sides, it falls under the kite category. If it has exactly one pair of parallel sides, it falls under the trapezoid category. Under the trapezoid category, we also get isosceles trapezoids, which are trapezoids but fancier. And the isosceles trapezoid says, well, on top of it being a trapezoid, the non-parallel sides are equal. That's as far as that classification goes. If it has two pairs of parallel sides, then we get a parallelogram. Parallelogram is the one that we get the most different kinds of classifications from, because two examples of fancy parallelograms are rectangles, which have four right angles, rhombus, which has four equal sides, and if it is both of those things, then we get a square. So we are looking at this giant flow chart, and we are going to have to determine, based on a graph of a quadrilateral, how can we classify these shapes? So that's what we're starting in 5.6 here. And we've already kind of been doing this. I don't know if you remember, we kind of did this with the parallelograms. We definitely did it with rectangles, rectangles, rhombi, and squares, where we were talking about, okay, what's the definition of a rectangle? Well, it has four right angles, so I needed to know that my sides were opposite reciprocals of each other. Rhombus has four congruent sides. I needed to use the Pythagorean theorem to tell that those sides were congruent. That's what we're going to do today. So if you look at 5.6, we have two problems that we're going to, or sorry, not 5.6, 6.5. We have two problems we're going to do. The very next page is this flow chart that also might be helpful for you to look at as we go through this lesson. It's kind of like a decision-making tree. Like, okay, once I figure out how many pairs of parallel sides do I have, then what am I trying to determine next to kind of continue breaking down what that shape is? So number one, at its core, I know that this is a quadrilateral. That's told to me in the beginning. I know it has four sides. Let's go ahead and plot this. So I have W, X, Y, Z, -3, -1, 3, 1, 10, -1, and 3, -3. I didn't like that last line. All right. There's my shape. What we are going to try to figure out first, and your notes are helpful because they kind of guide you through this, but the first thing we need to figure out is determining how many pairs of parallel sides do we have. None, then it's a kite. One, and it's a trapezoid. Two, and it's a parallelogram. So I'm going to literally count up my sides. And I'm going to do this because it got confusing last class. I'm not entirely sure why. We start from left to right. So the first one that I'm looking at is WX. W is on the left side. I count rise, which is up 2. Run, which is over 6. Reduces to 1/3. XY. Excuse me. I go from X to Y. X is on the left, so that's where I'm starting. I go rise, which is down 2. Run, which is over 7. So this is -2 over 7. Now here's where I think last class got confused, because you're trying to go counterclockwise, so you're in your brain, you're going, I'm going to go from Y to Z. But Z is on the left. So when I count my rise over run here, I got to start with Z. I go up 2 from Z, over 7 from Z. So this is a positive 2/7, not a negative 2/7. or a 7 to 7 halves. And then lastly, again, I'm going ZW or WZ, but I have to start with W because it's on the left. I go down to over 6. This is a negative 2/6 or a negative 1/3. Okay? So that's that. Now I've got all my slopes. Are any of these slopes the same? None of them are the same. They're all a little bit different. So I can say I have no pairs of parallel sides. That puts me directly into the category of kites. Ooh. Because kites are the only shape that have no pairs of opposite sides parallel. We don't even really have to say if anything is perpendicular because there's nothing after a kite. Kite is the only thing in that category. But if you want to just double check for me really quickly, are any of those opposite reciprocals? We have opposites, but not reciprocals. So we can also say none perpendicular. That's my first test. Now, here's where I gotta go back to my definition of kites. So you might want to go back in your notes a little bit. This is just one page I'm going here. Here's my kite. And then I've been highlighting these definitions for you so that we can really easily tell, like, what do we need to prove to make sure that this is a kite? To make sure that this is a kite, by definition, I need to know, are those two consecutive pairs of sides congruent? That's its definition. It's also here in this tree. If I know that I have 0 pairs of sides congruent, then I'm trying to figure out, okay, if the adjacent, aka consecutive sides are congruent, I have a kite. And if not, the most specific thing that we can say about this is that it's got 4 sides, it's a quadrilateral. So let's figure out if those sides are congruent, and if they are, then I get a kite. So the way that we're going to do this, again, like we've done all the other shapes, is Pythagorean theorem. I know that this side is 2 by 6, so for WX squared is 2 squared plus 6 squared. That's my Pythagorean theorem. And that gets me the square root of 40. I can do the same thing for WZ. WZ is also going to be the square root of 40 because this is also a 2 by 6. So those two sides are congruent. And I'm going to mark that in my diagram up here maybe if it lets me draw. Uh-oh. Hello? Oh, there we go. Okay. Then I got to do the same thing for the other two sides just to make sure that XY and ZY are congruent. So let's do XY. And I'm going to count my sides. This is a 2 by 7 this time. So by Pythagorean theorem, I get that this is the square root of 53. And then ZY is the same thing, the square root of 53. So I do get that these two pairs of consecutive sides are congruent, which is what I needed for the definition of a kite. So then when it says list all names that apply, well, number 1, it's a quadrilateral. So if it doesn't already say that, you should always list the quadrilateral part because it's got 4 sides. And then the most specific thing that I can say about this shape is that it's also a kite. Does that kind of make sense what we're doing here? We're following that decision tree, that flow chart on the next page, and we're hoping that it gets us to where we're going. All right, so that one was kite. So we're going to start over. So first of all, let's go graph that shape, WXYZ again. Oh my goodness. Negative 5, 3. And like, hopefully as we're graphing these, we can kind of tell by looking at them if we graphed well what we think this is. So that's always a good starting place for us when we're trying to prove things. All right, so first things first. Let's find slopes. Oh boy. WX up 5/2. XY up 2/8. So 1/4. Oh God. YZ. Now remember, I'm going from left to right. Y is on the left. So I go down and then over. So down 4/2. And then WZ. W is on the left, so that's where I need to start. I go up 3/12. Which reduces to 1/4. Okay, what does this tell us? Do I have any pairs of parallel sides or any pairs of parallel sides? Or how many do I have? What do I need to know for these to be parallel? How many? Dahlia?
1 pair.
I have 1 pair. It's the 1/4 right here, right? If they have the same slope, then they are parallel. So I have 1 pair of sides parallel. What category does that put me in if I think about my flow chart? What category of shape, Dahlia?
Trapezoid.
Yeah, trapezoid. Okay, do I have any, just to double check, do I have any that are perpendicular? No. 5/2, -2, none of those are opposite reciprocals. So I could just put a note that I have none perpendicular just to say that I checked. But this is the important thing that I'm gaining here. 1 pair of sides parallel puts me squarely in that trapezoid category. So if I have that 1 pair of parallel sides, the next thing I'm trying to determine, the only thing that could also be a trapezoid, is an isosceles trapezoid. By definition of an isosceles trapezoid, I know I'm doing a lot of scrolling. Let me go back to that isosceles trapezoid definition. But an isosceles trapezoid, by definition, is a trapezoid that has the legs congruent. So that's the only thing left for me to test now. Now that I know it's a trapezoid, I'm going to not do too much work. I'm just going to test my 2 legs to see if they're the same lengths. Hello? Erase a little bit. There we go. Here's the 2 legs. I'm going to go over them in blue. Oh my goodness. I'm going to go over them in blue so that we can see them. This does not want to like scroll today. I don't know. It's like not letting me touch it. What the heck? It's freaking out. Hold on. Pause. Those are the 2 legs. I'm testing if they're the same length. I'm using Pythagorean theorem. So I count. This is a 2/5. This is a 2/4. So maybe you can already tell, but WX squared equals 2 squared plus 5 squared. That's the square root of 29. And YZ is 2 squared plus 4 squared, which is the square root of 20. So not congruent, which tells me this is not isosceles. So again, I go down to the description. The number one thing all of my shapes should be quadrilaterals, because they all have 4 sides. This one had those 2, or the 1 pair of parallel sides, so this is also a trapezoid. And that's all we know. Questions there? Really quickly, I just want to show you a couple things because I know these are going to be questions. If I have a shape, which I will on the homework, that looks like this, the slope of this line is undefined, okay? It would be parallel to another undefined line. So if those two lines, if I saw them, I would say both of their slopes are undefined. I would say they are parallel if they're both undefined. Perpendicular to an undefined line would be a horizontal line. The slope of that is 0. And then please don't overcomplicate things. If you're trying to count the length of these lines and you're like, oh, but the slope is undefined, how am I going to figure out what the length is? You're counting boxes. Yes, they did ask this in first hour. All we got to do is count the lengths of these boxes. So this would be like 3, this one would be 5, right? Does that make sense? Okay. All right, I'm going to pass out your notes, or your homework packet. There are 3 pages, but it's only 6 problems. They just take up a lot of room here. 1, 2, 3, 4, 5.